Hey everyone, as a bonus to this course, I want to give you a quick overview of how the same quiz app backend we built using Ktor can be implemented using another very popular framework, Spring Boot. This will help you understand how things work in Spring Boot, and you will also see how similar concepts translate from Ktor to a Java based ecosystem. Spring Boot is a production grade framework based on the Spring ecosystem. It simplifies building REST APIs in Java or Kotlin with features like dependency injection, auto configuration, and built in support for tools like MongoDB and much more. While Spring Boot is primarily used in Java, it fully supports Kotlin as well. And that's what we will use here. For the build tool, I have used Gradle, but Spring Boot also works with Maven. To create a new project, we have Spring Initializer at start.spring.io. The entry point of a Spring Boot app is a class annotated with Spring Boot application. To configure the application, we use the application.properties file. Let's start with the structure. In this project, I have used the layered architecture. First, we have controller where we handle incoming HTTP request and respond with the appropriate message. And then we have the service layer. It contains the business logic. It gets the data from the repository and processes based on the request from the controller. Then we have repository. It communicates with the database like MongoDB in our case. Other than that, we have models where we define the domain models and the DTOs. This separation keeps the code modular and easy to maintain. Let's take a look at how we handle HTTP requests in Spring Boot using controllers. This entire class is annotated with REST controller, which tells Spring that this class will handle HTTP request and automatically convert the return values to JSON response. At the top, we use request mapping to define the base path for all routes inside this controller. In this case, every endpoint will start with quiz/questions. Each HTTP method has a specific annotation in Spring Boot. First, we have post mapping. It is used for post request, typically for creating or updating data. Next, we have get mapping. It handles get request, which is used to fetch data. And then we have delete mapping. It handles delete request for deleting the data. Other than these, we also have annotations for put and patch methods. You can also customize the path with each of these, like we have done in random and here in the ID. For methods that accept data from the request body, like when inserting a quiz question, we use request body annotation. This tells Spring to deserialize the incoming JSON payload into a Kotlin data class. When we want to extract query parameters from the URL, we use request param annotation. Here for the random questions endpoint, we need the topic code and limit as the query parameter. This lets us handle routes like this. If a part of the URL is dynamic like ID, we capture it using the path variable. This extracts the ID value from the URL path, for example this. Every controller method returns a response entity. This is a flexible way to send back a response where we can control both the HTTP status and the response body. Like here, we are sending back the status code 201 with created along with the success message. Now that we understand controllers, let's look at how we can connect our Spring Boot app with the MongoDB database. Spring Boot makes it really easy to work with MongoDB using Spring Data MongoDB. You just define your data model, annotate it, and Spring handles the rest. including most of the common database operations. Here is our quiz question data model. The document annotation tells Spring to map this class to a MongoDB collection named quiz questions. The ID annotation marks the primary key field. In this case, we are using MongoDB's object ID. Now, here is the magic. To perform basic CRUD operations like save, find by ID, find all, or delete by ID, we don't need to write any implementation ourselves. By extending Mongo repository, we instantly get access to a wide set of database functions without writing a single line of implementation. But what if we need more than just basic queries? Spring Data MongoDB allows us to define custom query method just by following a specific naming convention. For example, to fetch the quiz questions by topic ID, here I have defined one function with the specific naming convention like find by topic code. So here Spring will automatically generate the MongoDB query to fetch all quiz questions that match the given topic code. In this case, it's the same as this query. No need to manually write any queries. Just follow the naming pattern and Spring will handle the implementation. This makes Spring Boot a very productive framework. Now let's take a look at the service layer, which is one of the most important layers in any well-structured Spring Boot application. In Spring Boot, the service layer acts as the middleman between the controller and the database. It contains the core business logic, helping keep our controller lean and focused only on handling requests and responses. Let's start by looking at the quiz question service implementation class, the actual implementation of our service logic. The class is annotated with service annotation, which tells Spring that this class holds business logic and should be automatically managed as a Spring Bean. It implements a quiz question service interface, which interacts with the controller. This is a best practice as it promotes loose coupling and makes testing or swapping implementations easier. Here is how we handle a few common operations in the service layer. Here in this function for getting the random questions, we are checking that if we have received the topic code, then we will find the questions with the topic code. If the topic code is null, then we are going to find the all questions. Then we will shuffle those questions, then take the limited questions, and then map those questions to the response data class. Spring Boot service layer is where your application's real functionality lives. By keeping this layer focused on business rules and using interfaces, your codebase stays flexible, testable, and clean. Let's now look at how exception handling is done in Spring Boot, a really important part in building robust REST APIs. When something goes wrong, like invalid input, missing resources, or unexpected server error, we don't want to return stack traces or crash the server. Instead, we should return clean, consistent error response. Spring Boot provides a very elegant way to handle exceptions globally. We can define a class for exception handling globally and annotate with REST controller advice. This annotation makes this class responsible for handling exceptions thrown across all controllers. Inside, we use exception handler annotation to define how different types of exception should be handled. Here first we have one function which will handle any unexpected exception. This catches any unexpected exceptions and returns a 500 internal server error with a generic message. In next function we are handling the validation errors. This method catches validation failures. For example, when a required field is missing in the request body, it extracts all validation messages and returns a 400 bad request response with detailed error messages. Then we are handling the resource not found. This is a custom exception we created for cases where a quiz question or resource is not found. We throw this exception from our service like this. If the question doesn't exist, this exception is thrown, and our global exception handler catches it and sends a clean 404 not found response. As you can see, we are not using any try catch block because if anything goes wrong while executing the function, it will throw the exception and we are handling it in the global exception handler. So it will return the internal server error. Let's now look at how request validation works in Spring Boot. This is super important for ensuring that the data coming into your API is clean and correct before it reaches your business logic. This is the class that represents the request body when we create or update a quiz question. Let's quickly break this down. First, we have not blank annotation on the question field. It ensures the string is not null and not blank. Then we have this size annotation. It makes sure the question has at least 5 characters. Next annotation we have not empty. It checks that the list of incorrect answers isn't empty. Then we have annotation minimum with value 1. It makes sure that the topic code is a positive integer. We even go one level deeper and validate each item inside the incorrect answers list using not blank directly on the generic type. And here is the magic. We simply use the valid annotation on the request body parameter in the controller. If the validation fails, Spring will automatically throw a method argument not valid exception. And remember, we already handled that in our global exception handler earlier. So with just few annotations, you can ensure your Spring Boot API is protected from bad data with zero manual checks or boilerplate code. Next, let's take a look at how we serve static resources like images in a Spring Boot application. Spring Boot follows a convention over configuration principle. So if you place files inside the resource static folder, they will be served automatically. This means we can access these files using the URLs like http localhost 8085 images and then android.png. Now let's talk about one of the core features that makes Spring Boot so popular, dependency injection or simply DI. In simple terms, dependency injection means we don't create objects manually but let the framework provide them for us ready to use. This helps in separating concerns, writing cleaner code, and improving testability. In Spring Boot, we just need to annotate our classes with the right stereotype annotations like component, service, repository, REST controller. Spring will automatically detect and manage these classes as beans. Let's take a look at the controller. Notice something? We are not creating the service manually. We are asking Spring to inject it into the controller using constructor injection. Spring will automatically provide an instance of quiz question service when it creates this controller because this service is also a Spring managed bean thanks to the service annotation and the repository same story. This is also a Spring bean because of repository annotation. Spring uses its built-in IOC container to create, configure, and inject these components wherever they are needed. You don't need to write any new keyword or complex DI code. It's all handled behind the scene. Alright, that brings us to the end of this Spring Boot REST API overview. The goal of this video was to give you a glimpse into another powerful and widely used backend framework, Spring Boot. especially when we built our main backend using Ktor in this course. While Ktor is lightweight and Kotlin first, Spring Boot brings enterprise level features, robust community support, and extensive tooling, making it a great choice for larger or more complex projects. If you would like to explore the full Spring Boot version of this project, you can find the GitHub repository link in the video description below. Feel free to clone it, play around with it, and compare it side by side with the Ktor version to see the differences and the similarities in action. Let me know in the comments which framework do you prefer and why. I would love to hear your thoughts. Thanks again for watching. I hope this bonus video gives you the confidence to experiment with both Ktor and Spring Boot in your future backend projects. Happy coding, and I will see you in the next one.